In this video, we will see about the knapsack problem using dynamic programming. Let us define what is a knapsack problem. So knapsack is a kind of bag that has the capacity W, and there are several items, item 1, 2, and up to item N. Each item is defined with a weight mentioned as Wj and benefit or profit, or it is also called as value. So our goal is, in the knapsack, we have to put some items such that the weight of those items should not exceed the knapsack capacity, and also the total benefit or profit attained by those items should be the maximum. So this is the example we are going to take for solving the knapsack problem using dynamic programming. So here it is called as 0 or 1 knapsack problem. That means either the item is fully considered or it is not considered. For example, here there are 4 items. Item 1, 2, 3, 4. Item 1 is having a weight 1 kg and its profit is $10 or 10 rupees, you can assume like that. And item 2 is having 2 kgs, profit is 15. And item 3 is the 3 kg and its profit is 25. Similarly, item 4, 2 kg and 12 is the profit. So, and the knapsack capacity is defined as 5. So here within this knapsack, whose capacity is 5, we have to hold some items such that the items chosen whose weight should not exceed the knapsack weight, and also the profit attained by those items, selected items, should be the maximum. So in 0, 1, suppose here if the item 2 is selected, either 2 kg should be selected or it is the item 2 should not be considered. The partial of the item 2, that is 1 kg, half kg, should not be considered like that. That's why it is called as 0 or 1 knapsack problem. So this is the recurrence relation which is used to solve the knapsack problem using dynamic programming. So here I will explain this formula while solving the next step. So first, initially, we have to create the solution table like this. So here there are 4 items considered. So the items are mentioned like in rows. Item 1, 2, 3, 4. Here the value 0 also should be considered. One more row should be added. And the column is nothing but the knapsack capacity. So the number of columns depends upon the knapsack capacity. Here the given problem, the knapsack has the weight 5. So we are finding the solutions for the knapsack capacity 0, 1. Similarly, knapsack capacity 2, 3, 4, 5. And also the number of items. There are 4 items. So we have to consider 5 rows. So the item, the 0th row is meant for if no items is selected. So we have to create a table. So here this table, solution table is mentioned as B. And the columns are mentioned as J. Rows are mentioned as I. So here in this left side, here the weight of each item and the profit of each item is given. So in the step 1, so this is the initialization step. So here we have to initialize the item 0 and the knapsack capacity 0. That means here, if there is no item is selected, what is the profit? Here each cell is nothing but value of the knapsack. Okay, so here value V of 0, 0 means if no item is selected for the capacity 0, what is this current value? Okay, it is defined by this cell. So here, if no item is selected, that is, if none of the item is selected, in all the knapsack capacities, either if the bag is 0 kg or 1 kg or 2 kg, 3 or 4 or maybe 5, the profit is 0 only. Okay, so that's why here we are filling 0. Similarly, the first column, that is a 0th column, here if the knapsack bag is having 0 capacity, which can hold none of the items, so here the items also filled with 0. Okay, so we have to apply the formula for the remaining cells. So first we will consider item 1. So in dynamic programming, each item is considered in every iteration. So in the first iteration, item 1 is considered. During the next iteration, item 2 is considered. While solving or considering item 2, we will use the solutions of item 1 also. That is the logic behind the dynamic programming. First, let us see how to process item 1. That is this row. Okay. See here, this cell is calculated as V of 1, 1. So V of 1, 1, for that, if we use the formula, okay. So here, the weight of the item 1 is 1, okay. That is Wi, okay. Wi is, so I indicates the current row, okay. Here, I is nothing but 1. So the weight of the first item is 1, that is Wi is 1. Now we are considering the knapsack capacity for J, that is equal to 1. That is, so since J is equal to 1, equal to Wi, that is J is 1, Wi is also 1. So we are applying this formula. So this formula indicates, so V of 1, 1 is nothing but maximum of V of I minus 1. I is nothing but 1. 1 minus 1 is 0, comma J is 1, comma V of I minus 1, 1 minus 1 is 0, J minus W. J is nothing but this value, okay, 1, minus Wi indicates the weight of the first item, that is 1, plus the profit of the item 1. So here, V of 0, 1. V of 0, 1 is 0, this cell, okay, this cell, plus V of 0, 0. 0, 0 is 0, plus its profit is 10. So here the maximum of 0, 10 is nothing but 10. So this cell is filled with 10. So the meaning is the knapsack with the capacity 1 kg can hold the item 1 because its weight is 1. So now the item present in the knapsack is currently item 1 whose profit 10 rupees. Similarly, next we will calculate this cell V of 1, 2. That is 1, 2 means whether we are checking in the knapsack capacity with the 2 kg, we can hold the item 1 or not. Yes, definitely we can hold. Item 1 is, our item 1's weight is 1 kg only. So this item can be put into the knapsack with the weight 2. So here its profit is 10. If we apply the formula, here also we are getting the 10. It is 1, 2. This is row number 1, column number 2. V of 1, 2 is, apply this formula, I minus 1. I minus 1 is, I is 1. 1 minus 1, 0. J is 2. J, this is 2. Comma, V of 1 minus 1. I minus 1, 0. Minus J minus W. J is 2. Wi is weight of item 1, that is 1, plus the profit of item 1. So V of 0, 2 is 0. V of 0, 1 is also 0. 0 plus 10, 10. So the maximum of 0, 10 is 10. So here the value will be filled as 10. Similarly, with the capacity 3, with the knapsack capacity 3, we can hold the item 1. So the profit becomes 10. Okay, that is filled. That is also you can achieve using this formula. Similarly, knapsack capacity with the 4 kg and 5 kg can hold the item 1. So now the profit becomes 10 only. So now we have fully processed the item 1. Next, we will consider the item 2. So now what we are going to do is, while considering item 2, this item will be considered in this knapsack capacity, and also after filling this item 2, if there are any more remaining capacity, any more space in the knapsack, whether we can able to fill the item 1, that is also to be considered. So here this cell is V of 2, 1. So V of 2, 1. So V of 2, 1. So here its weight is 2. Item 2 weight is 2, but the knapsack capacity is only 1. So here 1 is less than 2. That is, this bag cannot hold weight item 2. So what we are doing? We are filling the same value in the previous row. Okay. This 10 is copied as it is. See here, we have I minus 1. I minus 1 is, I is 2, I minus 1 is 1. So 1 comma 1 we are filling. Next is bag capacity is 2. Item 2 weight is also 2. So we can put this item into this bag. After putting this item, the profit of the item becomes 15. The remaining capacity in the bag is 0 only because its weight is 2. Here also 2. So 2 minus 2. This item 2 fully holdable in the knapsack. So there is no space for holding the item 1. Okay. So according to the formula, V of 2 comma 2 is nothing but we have to use this formula because the knapsack weight is now it is equal to the weight of item 2. For this cells, knapsack capacity 3, 4, 5, it is greater than the weight of the item 2. So for these 4 cells, this formula to be used. So here what we are checking, whether the old profit is chosen, is considered. We of, now see here, I is 2, W I is also 2, J is 2. So 2 comma 2 is nothing but V of 2 minus 1 comma 2, 2 minus. So it can be holdable only for the knapsack with the capacity 3. So for the capacity 1 and 2, this item 3 cannot be chosen, cannot be holdable. So what we are choosing is, we are choosing the previous solution itself. So here this value is filled with 10. Similarly, this value is filled with 15. So this item can be holdable only in these 3 bags. So if you take the bag capacity with 3, we can hold item 3. Now the profit becomes 25. So previous solution also gives 25. The new solution also gives 25. So we can choose this item. That is item 3 is considered now. Item 3 is filled. So in each row we have to consider whether this item is selected or not. Since its capacity is equal to its weight, equal to the knapsack capacity, we can hold these items. If you take the knapsack with the item with the weight 4, we can hold the item 3. So there is remaining 1 kg left out. For 1 kg, we can get the profit is 10. So here 25 plus 10, 35. So here for knapsack capacity 4 kg, we can hold item 3 and also item 1. So 25 plus 10, 35. But the previous solution gives only 25. So here we can able to include item 3. So we are getting the highest profit now. Similarly, next this value. So V of 3 comma 5. For the knapsack with the weight 5, we are checking whether item 3, choosing item 3 gives the maximum profit or not. Yes, definitely in the knapsack capacity 5 kg, we can put item 3. It's now the remaining weight is 2 kg. For 2 kg, the maximum profit obtained is 15. So here 25 plus 15, that is nothing but 40. The previous solution gives only 25. So whether we choose the previous solution or the new solution, that is new solution means by considering item 3 gives the best value or not. Yes. So what is this meaning? 15 comma 25 means this 20. Why if you fill this item 3, the profit is 25. What is this 15 means? The knapsack capacity is 5. Item 3 weight is 3. So the remaining weight is, the remaining space in the knapsack is 5 minus 3, 2. So there are 2 kgs left out. For this 2 kg left out, the maximum profit that can be usable is 15. So that we are filling here. You can also see here the maximum of 25. The previous solutions 25, comma V of 2, comma 2. V of 2, comma 2 means in the previous row we are choosing the profit from the cell 2, comma 2. The remaining capacity of the bag, that is 15 plus the profit attained by the item 3. So now it is 40. This cell is filled with 40. So the last row indicates item choosing the item 4. Okay, so item 4 the capacity is 2. So we cannot put item 4 with the capacity 1. So we are choosing the previous solution itself. So this formula will not work here. So since J is means 1 is less than the weight of the fourth item, that is 2, we are copying the value from the previous row. That is I minus 1 means 4 minus 1, 3, comma 1. So 3, comma 1 we are copying. That is this value we are copying here. Next, this value, since capacity is 2, weight is also 2, we can put this new item 4 in this bag. If you put like that, the profit becomes 12. But the old profit is already 15. Which one is the maximum? The 15 is the maximum. So we are choosing this solution itself. So that means by considering the item 4, the profit is not maximum. The previous solution itself gives the maximum value. So we are not choosing this new item here. So this value is copied here. For the capacity 3, this item is chosen. If you choose this item 4, it will give the profit 12. The remaining capacity is 3 minus 2, 1. So for the item 1, for the capacity 1, the maximum value attained is 10. So 10 plus 12, 10 plus 12. So 10 plus 12, 22. But the previous solution itself gives 25. So that is chosen as it is. Similarly, the next cell, that is V of 4, comma 4. 4, comma 4 means what we have to consider here, whether the previous solution is a good one or the new solution by considering item 4 is a good solution. If you consider item 4, its profit is 12. The remaining capacity is 2. For the capacity 2, the maximum value obtained is 15. So this 15, if you add with 12, it is 27 only. But the previous solution is 35. So out of 35, 27, if 35 is the maximum one, so we are copying this solution as it is. Next is for filling this 4, 5. So for the capacity 5, if you put item 4, the new profit obtained is 12 plus the remaining capacity is 5 minus 2, 3. For the capacity 3, the maximum value obtained is 25. 25 plus 12, 37. But the previous solution itself gives 40. So we choose this is the best solution. So 40 is filled here. So we finished this table. After filling this table, we are clear that the maximum profit obtained is 40. But we are not we could not identify what are the items are chosen that contributes the profit 40. So in order to find that, we have to process, we have to check this table. Okay, so in this table, what is the maximum profit obtained, the largest value? Identify that. Okay, so here 40 is the maximum value. Check whether the 40 is present in which row. So here this is present, the 40 is present in this row and also in the previous row. So that means this item 4 is not at all contributing. Item 4 is not at all contributing. Now we are checking whether 40 is present in the previous row. No, it is not present here. So this is the first time it is appearing. That means item 3 is contributing this profit. So we have to choose item 3. Item 3 is included in the bag. We can identify like that. After identifying item 3 is contributing, how much it is contributing? So its profit is 25. So out of 40, it is contributing 25. The remaining value is 15. So we have to check where is the 15. The 15 is here. So we have to check again whether the 15 is present in this row or the previous row. Here only it is present. This is the first time it is present in this table here. So the meaning is item 2 is also contributing this profit 40. Okay. So item 2 is included in the bag. So it is contributing 15 value, and also item 3 is contributing 25. So the remaining value is 15 minus item 2 value is 15. It is 0. So here that indicates only these two items, item 2 and item 3 are contributing the value 40. So the items in the knapsack are item 2 and item 3. You can check also whether now the profit is 40 by adding the value of item 3 and 2, which is 15 plus 25, 40. So in this way only we are solving this knapsack problem using dynamic programming. I hope all you have understood. Thank you.